Hey everyone, welcome. As an agronomist, I've stared at a ton of lab reports over the years. They can be pretty dense, right? But they hold the key to understanding what we're actually putting on our fields. So today, we're going to deconstruct one for potassium humate and really get to the bottom of what makes this stuff work.
So you've probably seen this stuff before. It comes in all shapes and sizes, powder, granules, flakes. But honestly, how it looks on the outside isn't the interesting part. The real story, the real power, is what's going on inside this black substance at a chemical level. And that's exactly what we're about to dive into.
Okay, so here's our game plan. First, we'll cover the basics of what potassium humate even is. Then we'll break down a real certificate of analysis. After that, we'll look at its physical properties. And finally, we'll connect all the dots to see what this means for you out in the field. Let's do it. All right, first things first. What exactly are we talking about here? What is potassium humate? Okay, so at its core, it's a type of organic fertilizer. And that word organic is super important. It means it's derived from natural sources, which is a massive plus when we're talking about building long-term soil health and farming more sustainably. Next up, let's get into the hard numbers. We're going to unpack the data from a certificate of analysis. Now, why bother with this? Well, a lab report is where the rubber meets the road. It cuts through all the marketing fluff and gives us cold, hard facts. It's objective, verifiable data that tells us exactly what's in the product, so we can make smart, informed decisions. Okay, check this out. The first number that just jumps off the page is this: at least 80% total organic matter. That is huge. Think of organic matter as the absolute foundation of healthy soil. It's what helps hold water, feeds the good microbes. It basically builds a better home for plant roots. And digging a little deeper, we see another key component: over 55% humic acid. Now, if you're not familiar, think of humic acid as a kind of nutrient chauffeur. It helps unlock minerals that are already in your soil but are tied up, making them available for your plants to actually use. It's a real efficiency booster. And it doesn't stop there. We've also got at least 50% fulvic acid. Fulvic acid is kind of like the express delivery service. Its molecules are much smaller, so they can get inside the plant and deliver nutrients directly to the cells. Having both humic and fulvic acid, that's a serious 1-2 punch for plant nutrition. And of course, you can't have potassium humate without, well, potassium. This report shows at least 12% potassium oxide. This is a direct source of K, which is an absolutely essential macronutrient for plants. We're talking about everything from stress tolerance to overall plant vigor. So, let's just recap those key numbers all in one place. You've got your massive organic matter content building up the soil. You have both humic and fulvic acids working to make nutrients available. And you've got a solid dose of potassium. See? It's not just one thing, it's a whole package working together. Okay, so we know what it's made of, but how does it actually behave when you try to use it? These physical chemical properties are just as important as the chemical analysis for practical on-farm success. This first one might sound simple, but it is an absolute game changer. It's completely water-soluble. And why does that matter so much? It means you can easily mix it into a tank and run it through your drip lines or sprayers without worrying about clogged nozzles. It's all about ease of use and efficiency. Next up, pH. The analysis puts it between 9 and 10, which means it's alkaline. Now, this is a really key piece of information. If you're working with acidic soils, a product like this can actually help buffer that acidity, which can unlock a whole range of nutrients that were previously unavailable to your crop. And finally, there's the physical form. You can get it as flakes, a fine powder, or even granules. This is all about flexibility. It means that no matter what kind of application equipment you have on your farm, there's likely a form of this product that's going to work for you. Okay, so we've looked at the chemistry and the physics. Now for the most important part. What does this actually mean for agriculture? Let's connect the dots. Remember that water solubility we mentioned? Here's the payoff in 3 simple steps. You mix it with water, it dissolves completely, and it's immediately ready to go. This makes it absolutely perfect for modern systems like drip irrigation or foliar sprayers. It's simple, clean, and efficient. So, to really sum it up, the lab report shows us a few key practical advantages. You get a high concentration of organic matter to build your soil. You get that essential potassium for your plants. Its water solubility makes it perfect for modern irrigation, and the different physical forms give you options. It really covers all the bases. Okay, and this is a really important point to make. We need to be honest about what a lab report can and can't tell us. It tells us what the product is and its physical properties. It confirms what's in the bag. What it doesn't tell us is the specific biological outcome, like exactly how much it might boost root growth or increase yield. That's what field trials are for.
But look, being able to analyze products with this level of precision is a huge step forward. It lets us farm smarter, not just harder. And it really makes you think. As we get even better at understanding these complex organic products, what does the future of agriculture hold? It's pretty exciting stuff. Thanks for geeking out on the data with me today.